Seeing this move a little bit has left me very much itchy to actually properly control it. Now, I don't know if I'm going to have to do some more work to do things like press the accelerator switch. If I do, I'll do the most minimum I can for now, like just physically add a switch or whatever I have to do. Yeah, let's get this thing spinning. Oh, before I get started, I had a lot of fantastic comments on the last video. One of them was, I screwed up when I was putting the fuse in here. I did the spring between the fuse and the end. That's not how it's supposed to work. The spring is supposed to be behind the contactor. So you put the spring over the wire, you put the housing over the wire, and that pushes out on the pad that presses up against the side of the fuse. One of the other things I want to do in this video is, I realized I need to keep this battery charged up, but I'm not really putting a lot of power in, or I'm not really pulling a lot of power out of it. So if I set my solar panels back up, even though it's the middle of winter, I'm probably not going to get much yield. It'll probably be enough to keep the battery up and running. All right, first, this is off, so there should be no here. Let me verify that. Oh, there is power. Main switch is off. What's the voltage on the battery? 53. Power here? 43. Is that... Whoa, that contactor is hot. What's going on here? Let me go get the thermal camera. This FLIR camera is nice when it works, but it's always so finicky to get started. Oh, FLIR, you're almost as bad as GoPro. You can see the contactor is at 42 degrees Celsius. Did I leave it on? That's off. But the battery is off. How is there still power? 53 volts. I left the resistor on. I left the pre-charge resistor on. How warm is... Okay, that would be cold. Yeah, the pre-charge resistor's warm. That's exactly what I did. Okay. Bollocks. Okay, so now... What was that? Was that it discharging? It is currently on. It bled out the power and then shut down. I bet you I've got no voltage now. No volts. Okay, that's what it is. Okay, well, chalk that up to another lesson learned. Well, and that's why we do checks like this. So now I wonder what state of charge that battery is in. I wonder if I'm getting any solar right now. Would now be the time to set up the solar? It might be, you know. Yeah, let's set up the solar first so I can start charging this up, because even though it's really dark in here by the camera's standard, it's 2:30, so it's winter time. I probably won't get a lot of sun, but might as well put a little bit into it. So it's been a long time since I played with the solar. So for those who haven't watched the old videos, way back in the early days, I put 2 pairs of 2, each pair in series to get a high enough voltage. These are the 2 pairs. If I get these panels up to 200 watts during the day, I'd be ecstatic, but that's enough to keep the batteries topped up. So these are currently taped off with the positive offset from the ground, and they are going into oh no, these are actual breakers. Upstairs on the ceiling, or on the roof, I have breakers that have the replaceable glass fuses. These are actual breakers. I think they're 20 amps each. These break the ground and the positive. Before I energize it, let's put these on. I usually had a box with a DIN rail, but that's downstairs in the basement. These won't be talking to the Turbo GX because that's down in the basement, unless they happen to be able to have a strong enough Bluetooth signal to be able to reach downstairs. I have a feeling I won't be taking these MPPTs with me. Ideally, on the boat, I would have one single panel that's higher than 60 volts so that I could run one panel per MPPT, and I could use these nice and small and relatively inexpensive 120s. But the problem I have is most of the panels I've been looking at, I'm going to need a series 2 of them, but that's going to put me close to the 100 volt range, like 80 volts. Which might not sound like a lot, but the voltage coming out of a solar panel goes up as things cool off. So I've got a spreadsheet, because of course I do, where it does a calculation on the coefficient of temperature to figure out what would the voltage be at minus 30 Celsius. I don't think I'm ever going to hit minus 30, but it's not outside of the realm of possibility, and I'd hate to have it get really cold and the voltage climb high enough that it fries these. These get destroyed if the input voltage goes above the rated voltage. So I'm probably going to be using 150s or something like that. So yeah, these will probably just be staying in the house. Now, It is daytime outside, so where I was relatively cavalier with these, I have to be much less cavalier with this. This is also going to be high voltage. So I think the two panels together are 70 volts or something like that, which I've got really dry skin right now, so I probably wouldn't get a shock of, but I'd rather not test that theory, you know? Okay, it is currently safe. The output of the MPPTs are still flopping in the wind, but with the breakers off, there's no power going to here, and I can tell because there's no activity light, so I know that the outputs are still dead. All right, what voltage are we dealing with right now? We are looking at 84 volts, so she's definitely alive. Okay, get them far apart. All right, so again, breakers off, red to red, black to black, red to red, black to black, off, off. And out of curiosity, do I have voltage on the other one? Because I haven't used these in a while, it's entirely possible that squirrels have done a number on my panels and one of the groups isn't working. 85 volts. Nope, they're both working. I suspect I don't need to say this for anyone who's been watching for a while, but the way I'm about to wire this up is very temporary and not advised. Let me show you what I'm going to do. So, unfortunately, the old Regen never did get to use it. Should probably sell it, so I don't think I'll ever use it at this point. But I'm running super low on this cable, and these ground wires aren't quite long enough to reach that post. So I'm going to use a bolt going through here to hold these together, and then I'll cover it in tape, because this will be running at low voltage, but it'll still be, well, that's the ground, but I'll be doing something similar on the hot side to get to this post. Whenever I have one tool of something, even if I don't think I'm going to use it, I'm really reluctant to give them up because so many times in my life, tools I didn't think I had a use for saved my butt. Hey, Cap. Well, anyways, that's not right now's problem. That's going to go like that. This is so not okay, save for the fact that it's temporary, and again, low voltage on this side. I sometimes wonder, the couple who built this house in 1967, I'm the second owner, I bought it off the guy who built it. Never spoken to him since, and that was about 8 years ago. He was an elderly gentleman, so. In any case, I wonder sometimes what they would make if they walked back into this house and saw this in what used to be their fancy dining room. I hope they wouldn't regret selling it to me. There. I know it's the wrong color. I don't know where my black is. I'm going to insulate this as well. Even though this is the ground, it shouldn't matter. I take my risks, but I don't take them unnecessarily, you know? A little bit of tape doesn't hurt anything. Oh, I just realized I was going to run the... Oh, that's okay. I can turn these off with the breaker. I was going to run them to these posts, but that means that even if the battery was off, the solar panels would be charging this or energizing this. But I can turn off the solar panels with the breakers, so that's okay. They have their own disconnect switches. This, which is still surprisingly warm, this is still a switch to control this. These are protected by the breakers. This is protected by this switch. This fuse, this A&L fuse is more than enough to protect against anything that these might do. So yeah, okay, we're okay, we're okay. Gotta get a deep socket that's the right size. I need a whole new socket set. Problem is socket sets are surprisingly expensive. Though, one of the comments in the last video, he was like, he, she, them, I don't know who they were, said, why don't you, or you really need to get a pair of insulated socket set or the stuff that electricians use. And I'm like, yeah, I know. But in a sign that they clearly know what motivates me, they pointed out the fact that it comes in a wonderful shade of orange. They know me well. Also, somebody fact-checked me on the ABYC requirements. Apparently you're allowed 4 ring terminals per post. Okay, I need a red cable to get... Actually, are these long enough to get down here? Okay, but then I'd have 6. Yeah, you know what? That's fine. This is all temporary. Oh, I'm gonna have to turn on the battery to charge the battery, which means I need to turn that on. I think I am gonna put a switch on the pre-charge. They were so adamant about making sure this thing always had it. What's better? If this is off, but the pre-charge resistor exists, If the pre-charge resistor is here, these posts are always energized. If I put a switch on it, I can completely de-energize the controller, but then it's on me to not to forget to re-enable the pre-charge resistor before I power the system up. Failing to do that could damage the controller. I need to think about this. I really need to get another bus bar. So I'm going to have to turn on the battery now, which means I need to run the pre-charge resistor to bring this up to voltage, flip that on, which means there's power coming through, but only through this, and this should still be off because the key switch ignition is off. Okay, so this is definitely off now. Okay, so right now it's seeing the SmartShunt from down in the basement. I can't find what I did with the old push button switch I used to have on the other box. I need to find that again and then swap this out. The problem is this is not momentary contact, it's latching, which is why I was able to leave it on where I couldn't before. Anyways, okay. Oh, it is momentary contact. 1, 2, 9, 10. There we go. Now the question is, if that's momentary contact, how did the resistor stay on yesterday? I am still confused about that. Okay, well anyways, I should now see 50 volts across the controller. I do. And I now see the two solar panel, or the solar charge controllers, because they're picking up power off of their the battery side. The other SmartShunt just came online. Oh, got to change the battery capacity. This is when it was set up for the boat's 12 volt system. Charge voltage is, okay, I'll do 58. Low voltage alarm needs to be configured. Set this to 46. Okay, so now it's reconfigured again for 48 volt. Hey, bud. How do I change the name? Is it under product info? Yep, that's it. SmartShunt 1 by 48. Go back, go back, go back. Why is the charger off? Okay, so it sees no input voltage. So actually, let's fire these things up. We should start charging the battery. It's gone into bulk and bulk. How many watts? 30 watts, 60 watts, and 40 watts. Oh, you know what? It's a little over 100 watts. Ain't much, but it's something going in. Now, the voltage on the controller should be higher, but this controller was specifically selected for Regen off the prop. That's why they told me to get the 72 volt version, so this should be totally fine. Why is that 53 volts? Well, anyway, that's the solar setup. Now, we've got some charge coming back into this. What a sketch setup this is. Solar pixies come in through safety boxes to smart boxes to spider to battery into load. All right, it's been a couple of days since I last had the camera going, partly from day job, but partly because I was starting to merge the pull requests that were coming in from other folks to significantly improve the code on the helm control. While I was doing that, I also sat down and started reading up on all of the steps I still need to do in order to be able to use the helm to control this. I've been reading the manual and taking notes on the document, which I linked in the last video. I guess I'll link it in this video as well. And I haven't finished going through all the configuration steps, but I've gotten through most of it. But I hit a point where there are switches I need to be able to press, like the forward, neutral, reverse switches, which, because I'm using the joystick mode, become low speed, mid speed, high speed. Those switches work by this sending out 12 volts on one pin, and then depending on the function, when you close the switch, it closes the switch down to the appropriate signal pin. Sorry, I'm not explaining this well because I'm still learning it. Point is that when you flip a switch, it closes the circuit. Future Maddie here. It's at this point in the video where this failed. This is my lavalier mic. I don't know why. I'm going to guess it's this part here because it was sitting in my pocket, but the audio starts popping from this point through the rest of the video. This video is probably the single one with the most raw footage, so Murphy was for sure going to have me have a failure without me noticing it for the longest period of time. I'm very sorry. As I edit this, I'm going to do everything I can to try to salvage the video. If it seems to be a little bit herky-jerky or jumping, it's probably because the audio was completely crap. I'm not a big fan of doing voiceovers. I'm going to do the best I can to salvage this. I'm sorry this video isn't going to be up to my normal standards. Not that those are very high anyways. Onward with learning how to make videos. Now, back to our regular scheduled motor building. Oh, before we go back to our regular scheduled motor building, a lot of folks in the last video were commenting about, hey, you can get a kit. There's a lot of these things. Did you know you can get a set of tools for popping pins out of connectors? Thank you very much. I've got them. I don't need them right now because that part of the job is over, but I've got a lot of pinning in front of me, so these are going to be really helpful. Thank you to everyone who suggested. An update. I set up the solar chargers to keep this battery topped up. I was generating very little power, but even so, by the second day, these batteries were top balancing. So, I mean, I knew they were pretty full, but this is going to work really well to keep this topped up, I think. I mean, obviously, once I run the motor a lot and I burn up a lot of power, there's not a lot coming out of here to charge that up. But for the meantime, it's plenty. Hey, Mr. Tatters. Hi to YouTube. Old man has to always take a bit of priority. Eh? Hey, bud? The leads for this don't need to be very long. Where the throttle position, I want to have much more length on it. This one, I don't need much length on. That should be plenty. So what I'm trying to do here is figure out how to use the new potentiometer. It doesn't have a clear, put the +5 in here, and the ground comes out, and the signal comes down the center. What I came to realize by reading the spec sheets, which is what I'm doing here, is it depends on whether you want it clockwise or counterclockwise rotation. I wasn't sure which one I wanted, so I just picked one and went with it. This second potentiometer is going to feed into a second DAC. I got two of them, one as a spare in case I blew the first one up, but it ended up being useful because I have to send a 5-volt signal to the controller to tell it how aggressively I want the regen to be when I'm under sail. The trick with having two DACs at the same time is how do you address them separately? So there's a little pad on the circuit board that comes with the DAC that if you solder it, it changes the address that it's going to be listening for signals from the Arduino from. So I'll be soldering that short and then figuring out what the address is. I still have a lot to learn. I should now have... Okay, yeah, the address pin is bridged now. That is hardly elegant, but it does the job. Slowly learning my lesson and tinning before I solder. Okay, that's a pretty horrible soldering job, but oh god, that's terrible. Okay, I gotta redo the ground. Put a couple JST connectors on it, and I think this is largely done. The hardest part I'm finding with these JST connectors is you're only supposed to, well, there's no way you can see this, but you're only supposed to expose about 2 millimeters, and you have to stick it in so that the insulation stops after the outer wings, but before the inner wings. It's a very narrow window where you can see where the insulation ends. I'm getting better at it, but it's definitely an acquired skill. Like I said, I'll do a video showing how I'm doing this once I get better at it. And I'll set up the camera so you can see what I mean. So that is the second DAC setup, which means I'm going to have to run new wires because I need to move this down some. I need to rewire this whole thing. Okay, let's get this out. You know what? I bought a new breadboard. I'm going to move everything down to the new breadboard. That way I can use this as a reference. I was going to try to use the top breadboard as a template as I moved things down to the lower breadboard. I didn't do a good job at it, but that's what you're seeing here. So now I need to pick up the 12 volt and the 5 volt and bring them onto the PCB, and those will feed into here somehow. I don't know how yet, and I probably won't get to it tonight, but yeah, that's what I got to do next. One of the things I was really struggling with when I was trying to move the parts down to the new breadboard is that I forgot how to use the DAC. One of the things I eventually realized was that there is a clock pin and an address pin that comes from, I believe it's the I2C header. I'm not quite sure what that is. I'm still learning. However, once I realized that the clock was just the clock, and so that everything beat it in the same time, that's a really bad way of describing that. But anyway, the address pin then had to run to the DAC. I was really confused because it looked like I had to run the same wire to the same pin on both DACs. I did. The whole point of the address pin is that the Arduino, Cduino, whichever it is, can say, hey, DAC at address X, I'm talking to you, and send a signal. It took me a bit to figure this out, but once I did, it was pretty straightforward. You take the clock and the address pin from the I2C, which I traced by touching the pins on the header to figure out which pins they are on the side of the Cduino, and just run it to the same pin on both, just like a bus. It's a bus, that's what it is. All right, now the clocks should all be linked together. Oh, clock to clock to clock. All right, and I've got no short, no short, no short. Okay, green for the address. That is the second pin. Should now go to SCA. Oh, did I do that on the wrong side? I think I did. And this is why I check. Okay, now it's correct. I had it in A6, it had to go into A4. It's going to be so nice to turn this into a proper circuit board that doesn't look like such a rat's nest. In time. Barring mistakes, the new wiring is done, but I'm tired, which means I might well have made a mistake, and if I try to debug it while I'm tired, I'm likely to miss my mistakes. I need to go take a rest, get a clear head, and then tomorrow after work, I'll take a look at make sure I didn't make any mistakes, and then I'll be on to learn about the Darlington array. After turning off the camera, I took a picture of the new layout on the new breadboard, and I shared it on the Discord I have for patrons. And one of the users, Stick, was like, hey, why did you plug the ground into the positive? And I'm like, what? So I knew I had to fix that, and here you can see it on the left there. The black wire is right into the same row as the red, and it shouldn't be. But while I was setting up to fix that, I also noticed that I completely mangled the pins on the Darlington transistor array, the ULN2003a, that I'm going to be using as switches to flip the foot switch and the forward neutral reverse switch and whatnot from the Arduino. I need to fix these things, and this is why I don't turn things on when I'm tired. If I missed it making it, I would have missed it checking it, and I would have turned something on, and, well, I probably would have destroyed the DAC. So let me get that pulled out, let me fix the ground wire, and then I think before I do the rest of the switches, I want to download the new firmware and make sure that the new DAC and pot are working. That way, when I move on to the switches and I start to diagnose and test that, if there's any problems, I'm not dealing with a whole lot of problems all at once. I always buy multiple parts when they're cheap and I'm using them for the first time because I fully expect to do things like this. To anybody who's used to electronics, this is going to seem pretty obvious, but there is a half circle marked on one side. That's how you know which one is pin 1, which I'll double check, but I believe it's the top left pin and as I'm holding it relative to that half circle. So now, not messing this up this time, hopefully. The way that this is supposed to work is that you take the 12 volt that's coming out of the controller and I run that into the, I think it's called like the common collector. And then as you provide a signal from the Arduino on the input side, it closes the circuit to ground, allowing the signal to be pulled low. So normally, how would that work? Yeah, so I have a 12 volt coming out, and normally if you close the mechanical switch, it would close the circuit to ground, and that's how the controller knows that you flipped a switch. Right, now I need to fix that ground. There, so now that's wired up properly. Don't feed the trolls, but remember in the last video I was saying about how some people seem to be cheering your failure? That short will totally disintegrate you. Don't worry, I'm sure it'll be quick. Again, the vast majority of people who post comments have been absolutely awesome and super encouraging, and I love that and I appreciate that. So I'm going to immediately put that off my mind. Let's get back to it. I think for some people that are rather negative, they see a project and they think to themselves, I couldn't do that. And then they see the person trying to do it and they think, there's no way that person can do it if I can't do it. And I think they're negative because a small part of them doesn't want somebody they think isn't as good as them to succeed at something that they don't think they could do. Which is a shame because I think most people could do a lot more than they think if they gave themselves a chance. What I want to do first and foremost is to make sure there's no short between the +5 and the ground. That would be bad. And this test I'm about to do would have caught the wiring mistake that I made because, no, maybe it wouldn't have because I put the ground into the positive so the short was through this, and I bet you they've probably been smart enough to put a diode in here to protect it. In any case, I'm going to check for a short. Key thing for me is don't let people who can't see their own potential try to take away from your potential. We're going to do continuity test. No continuity. Actually, there should be no voltage either. Let's do a voltage check. Nope, no voltage. Okay. Oh, actually, you know what I can do? I'm going to put that back in, and I'm going to put my grabber McGrabby thingies on, and then I can go along and touch all the other 5 volts to make sure that everything has voltage. So I should be able to go V in. I should go V in. Okay, excellent. Is there anything else? I should see continuity on this pot and on this pot, and I do, and I have one here. Yep, so all the positives are good. Let's take that, pull that out, put the ground in. I love these little grabbers. Okay, now I should do all the grounds. So I've got a ground. I've got a ground. This should be connected to ground through the switch. And it is. And now the ground pins of the first pot and of the second pot. Okay, that's all good. I like this camera for a whole lot of reasons, but it randomly turning itself off is not one of them. So let me try that again. When I started the first video on the helm controls, a few people commented saying, what happens if this becomes unplugged, or the cable is broken, or shorted, or. And when I was reading the configuration options for the Kelly controller, it has something called the throttle, well, TPS, throttle position sensor. TPS dead high and TPS dead low. I've not yet configured those, but I'm going to set them to 1 and 99. And what that does for 1 being at the low says that if the incoming voltage goes below 0.05 volts, consider the throttle to be disconnected, as if it got unplugged. If it's above 4.95, the 99 value, then consider it to be a dead short. In both cases, it then ignores the throttle. So I modified the source code some. Let me see if I can see where. I tried setting, so here, the throttle DAC minimum I set to 50, which is 0.05 of a volt. And I set the maximum, where's the DAC max? Oh yeah, the DAC maximum to 4054 out of 4096, which is 50 short. 50 short minus 1, it's off by a little bit. I was checking the math at least to make sure that it never, full throttle never went above 4.95 volts. And though the math was right, clearly now that I'm running it, it's not, because when I go full throttle, and what's odd is it seems to bounce. Watch it, 57. Oh no, it hit 57 and stopped. And it's seeing a smoothed input, a raw input of 663. Oh, the dead zone. Oh, okay, so that's what's happened. The dead zone's gone far too far forward. But it does go full forward. Okay, so that part of the code is right. Sort of. Oh, because I fell off the resistor. So the part of the code is right, but the spacing or the stepping is not. The max value and the min value. I'll fix that in code later. But for now, this is enough to test. Actually, I'm going to turn off the camera for a bit because I realized the debug output that you're seeing scrolling at the bottom is for the throttle. I need to modify it so there's a different debug that I can switch between to show the potentiometer raw value and its output voltage. So it's going to be pretty much the same thing as you see here. It'll just be for that, and I don't think you need to see me sit here and program that. So I'll be right back. So that took a bit longer than I expected. One of the changes I wanted to add into the code, which I've done, and I'll go into this more in the episode when I dedicate more to the helm control itself, was from somebody who sent me a pull request that showed initializing my smoothing array before going into the main loop simplified things. So I wanted to integrate that as well as setting up the system now to have the two throttle potentiometer, regen potentiometer, throttle DAC, regen DAC. So I had to do a lot of renaming and excuses. The result is that now it's dark out. Space for the screen recording. Without going into too much detail, because that'll be the next episode, what I have done is all of the existing variables I prefixed with throttle, and I basically duplicated most of them with regen. The main big difference between the throttle is that I have this neutral point, which you would have seen in the previous video, because 2.5 volts is neutral, and then above 2.6 is forward, below 2.4 is reverse. With the regen, it's just a straight dial, so it's way simpler, but it's basically the same idea. So I set the limits, and I go through, this is the, where is it? Void initialize array. This is something new to me. The initialize array, I had this thing where I was counting how many data pieces. How many times have I read the sensor and feed that into an array so that it would average properly as it filled the array for the first, well, I've set it to 8 loops right now, but it'd be like 32 when I put this thing into production. Point is, when it read the first one, if it tried to divide by 8, it would get like 1/8 the size, and then 1/4, and so on. So one of the viewers who gave me a pull request had an initialization function, so it just preset everything, then went into the main loop, and I didn't have to track that anymore. So it was simpler, and it meant that all of the data in the array had real values. Now, I have not actually loaded this code. I know that it compiles, that's it. This could blow up on me still. Yay. Oh, one of the other changes that's really good. Somebody else submitted a pull request where they said, listen, don't even read the inputs if the OPU switch is off. So I don't. So I check to see the switch state. If the switch is high, then I just set everything to the safest defaults. And if it's low, then I go ahead and read the sensors for the two potentiometers. I also, though I'm not using it yet, press the foot switch. So now if I flip the OPU switch, you can't see it, but it's just off screen. If I flip that switch, not only does it set the throttle to the midpoint, it also disconnects, or it will when I implement it, the foot switch, which is a second way of telling the controller no inputs anymore, like stop the boat, stop the motor. I expanded the debug, so if I've done this right, I'll be able to see the throttle position, input and output, and the regen input and output. I did not fix the bug, whatever's causing it, so I have to push the throttle way too far. Worry about that later. And then the last thing I did was I had to set up for two potentiometers. So you saw when I soldered up the second one, I bridged it. If I got it right, the regen DAC is 0x60, but you can see it starts with regen DAC where it used to just be DAC to separate it from the throttle DAC, which are set up here. Okay, enough yammering. Let's see if this loads. Oh, it doesn't even see the board. I've seen this before. I have to reset the Arduino IDE. Fine. Ooh. Okay, I can see that the TPS DAC setup is bad somehow. All right. So I'm actually going to pull it right there. So right off the bat, I can see that this is probably with the new setup routine for the array. It is starting off at minus 2650 millivolt. The TPS DAC is 2171, minus 2171. The regen started at 33 and started smoothing its way back up. That's cool. So that looks like it's okay. How did I screw up the TPS DAC? So the TPS real value was 265 and has stayed 265. The smoothed was 33. So the smooth value was correct. The DAC output is set to minus 2170. How did that happen? This might have been a bug all along because I think this is the first time I started with the helm all the way in reverse. I have an extension cable. Put it back into neutral, reconnect, and see if it does the same thing. Yes, it does start low. Has that always been a problem? Okay, so you know what, before you do that, does this work? Yes, it does. Okay, full clockwise rotation sets the DAC to 0, which I've currently got to 50 as the lowest value. And if I go all the way up to the highest, it should be 4095, or no, 4055. Okay, it's got the same bug that the other one does. What is the actual reading though? The Regen rating is 893. Smooth to 431. So the smoothing code is broken. And with this thing in dead center, it thinks that I'm in reverse 17%. It's like this whole thing has been like rotated forward in code. Why? Okay, I gotta tighten the screw. There we go. So that thinks it's forward 70, no. Okay, it was just messed up because I was tightening it. I gotta see what the cat's doing. 1 second. This is Mr. Tatters. He can't see anything anymore. But he can still purr. All right, let's get back to trying to figure out what's wrong. So that's about where it ends now, where it used to be straightforward. I wonder if it's because I added this length of wire, if that changed the resistance that it's reading. I bet you that's it. That's where I want full forward to be, and that is now 664. You gonna go for a walk? He's been resting in the kitchen since he lost his vision, so I set up a little comfy place by the heat register, and he's been sitting there a lot. Yeah. So I'm gonna go put him back there. I think he's happy there because he knows he's close to the food and the water. Oh, my boy. My poor blind boy. All right, I'll be right back. It was kind of sad but cute. Earlier, Tatters was on the couch beside me and he decided he wanted to get down, so he walked over to the edge of the couch and he was putting his paw out trying to figure out where the coffee table was. I knew he wanted to get down, so I started tapping the floor so he knew where to jump, and he was really hesitating. And Kepler was sleeping on the couch. He got up, walked over, gave Tatters a couple of licks, and then jumped down onto the floor. And just after that, Tatters jumped down. All right, let's get back to this before I start crying. So 664 we're going to set as the new throttle pot max. Throttle forward maximum. Change that to 665. So now I'm going to bring this to my tape mark that marked minimum value for forward. And I'm seeing 451, so we're going to call it 450. Now I want reverse to start right there. So that's the minimum reverse. At this point, this is when reverse starts to kick in, leaving the space in between as the dead zone. And that is 404. So we're going to make it an even 400 here. And now we're going to take it to full reverse, which is 265. Oh, it might be 265 right now. If I move it up, does it go to 266? That is suspiciously close to the original. No, it's not. So it's not going below what I said is the minimum. So I'm going to have to just pick a random low number, upload it, and see what the real number is, and upload it again. Let's change this to 100. I'm sure that's wrong, but let's try it. Okay, so the reverse is reading 225. Okay, so now I should have a real range. Let's see what we get. So this should be reverse 100%. Don't worry about the voltage values. We'll sort out one bug at a... Oh, the minimum voltage is 61 millivolts. That seems good. Okay, so if I bring it up just a touch, reverse 99. Okay, and if I bring it into neutral, this should now be the neutral again. And it is. And let's go to full forward. It's off by just a touch. Perfectly within realm of reason. All right, now for this. For the regen, I want full counterclockwise to be no regen. I want full clockwise to be full regen. And more importantly, the voltage is back to 5 volts. I think, well, let's confirm that. Okay. And I'm getting 4.3 volts. What is the DAC value I'm sending? 4027. That's not right. 4027, which should be 4.9 volts. So why is this reading only 4.3 volts? Out of curiosity, what voltage am I getting on the other DAC? See if we're even talking to the right DAC. I see it's got a green light on it, but the voltage is currently 2.2. If I change this, does it? No, this is not changing. Tells me I've got, do I have the address of this thing wrong? Ooh, zoomed in. I should be fixing one problem at a time. I'm bouncing around. Yay, ADHD. Ah, now I think it's working. Oh. All right. It's capping out at 3.85 volts. It thinks it's saying 4337. Okay, so at least I've got the right address on this. So let's go back to focusing on one problem at a time. If I'm sending 4054 and it thinks the voltage is 4948, why is it actually 4.38? Okay, let's set this to 4095 just to see what the max voltage is. So now it's sending 4095, which it thinks is 4.998 millivolts, and I'm only getting 4.4. Why? Is it a bad solder joint? It has the voltage out pins right on the DAC circuit board. Sorry if I get in your way here. My own vision hasn't been the best since I got COVID. 4.4. So no, that's actually the DAC voltage. All right, I need to phone a friend, so I'm going to turn off the camera and I'll be back, hopefully with an answer. Actually, while I wait, I messaged my friend, but I don't know if he's around yet. I wonder if I get the same kind of voltage output on the other DAC if I send 4095 to it. So I'm going to do the same thing, set the DAC minimum to 4095. Pot is currently 895 to 0. So 895 is the max. So I've set the pot to 1024, which is what it should be reading, but for whatever reason, the ADC is not reading that. So let's try setting 895. So let's do 890. That way I have a number that can actually be set as the maximum. So if I hit that, if there's a little bit of wiggle at the end, I know I want 100%. All right, so now the voltage is ramping up. And it's doing the same thing. It's capping out at 4.41. Oh, and the DAC is set too high, because now the DAC's set to 4118. That's not good. Regen DAC maximum. Am I not putting that through a constraint? How's that? What? What is going on here? Okay, you know what? I need to fix the smoothing code now. Okay, I'm going to put some more thought into this, and then I'll bring you back. I'm going to change the batteries and charge things up as well. I mean, I don't know how I'm going to edit this together into something interesting, so yeah, I'm just going to figure this out and then show you what I did. In case you're ever wondering just how much of a noob I am at all this, I took the loop during setup, that new initialize averages array, and then never actually called it, which is why it was thrown off. I foolishly thought I was spinning the motor tonight. As I sit here right now, it's almost 11 p.m. I had this grand idea. I was going to wake up, jump into this, need a few hours to get the code sorted out, get the last switch set up, and configure the controller. If there's one big lesson that I've taken so far in this is when you're taking on a big project, you have no idea how long it's going to take. You don't know what you don't know, so how can you possibly come up with a reasonable estimate of how long it's going to take? Holy... Okay. Start a screen record, and then I'll show you what I did. So here in the setup is where I was supposed to be calling this averages, this function. I think they're called functions. The way I realized that I wasn't calling this function is that I put in some logging and it wasn't actually recording anything. I'm like, wait a second, why? And I realized what my mistake was. Let me see if I can restart this. So I'll stop it there. So you can see the I0 through 7. That's the 8 iterations that I wanted. Later it'll be 32. Anyways, there we go. So at the very beginning, when this thing first turns on, it should go to the neutral position and then start smoothing out to whatever the real throttle position is. So let me actually do that. There's a delay in this because I was slowing it down so I could actually see the output. All right, there we go. So you see it starts at 425. On the first iteration of the first sensor reading, it's starting to climb up, and it should go over 8 loops to full throttle. There it is, full throttle. So that's good. Now, what I haven't tested, because I just brought you back, is if I set this all the way to full reverse, which is right about there, and I reset, do I get the same thing? So it starts at 400, or 425, but first iteration it drops 400, 375, 350, so over 8 iterations this should go to 100% reverse. There it is. So my throttle is working. Now, the voltages are still 4.4 volts. That I don't know. I am sending the right value to this DAC, I am sure. While I was doing all of this, I had an idea. Now, what I wanted to do to make this super simple is I want to, in the main loop, do nothing but statically set 4095 to both the DACs. Well, actually right now I only care about the one DAC, just to see if it actually goes to 4.9 volts, or 5 volts, thereabouts. If it doesn't, that tells me the DAC is acting up, or the way I'm using the DAC is wrong. I'll do that, and I can put the on screen right here. So right now I'm getting a solid 4.41. So let me just do 4195. In theory, this should overflow and go to a low voltage. And it's still 4.41. I don't know what I'm doing wrong here. If I set this to 2048, does it go to half? Oh my God. This whole time I've been reading the wrong DAC. What makes these kind of things really hard is that you've got so much going on, you're trying to take in so much information that you just keep making the silly mistakes because you're spending so much time trying to think about the complicated things. So my earlier test where I went over 4095 was invalid because I was reading the wrong, yeah, okay, so now it's 2.26 volts. Okay, let me go back to 4095. 4095 is 4.4 volts. Okay, so we're back to that. Now let's do 4195 and see if it overflows. 4195 overflowed. Let's do 4096 and see if that's the overflow point. Yeah, 4096 is the overflow. 4095 will go to the highest voltage, and that's going to be 4.4. Something is up with these. Is it not getting enough voltage from the USB, I wonder? Am I just simply pulling too much power from the USB port? Okay, I need to get more 5 volt onto this. I think I'm not actually running into a software problem or a hardware problem. I think I'm running into a voltage problem. Okay, you know what? I'm going to assume that the code is right, and the fact that I can't hit 4.4 volt or 4.9 volts is a problem I'm going to solve later. Now, one of the things that this has an option for, and I think I need to implement in my logic, is that if the throttle position is not in neutral when this powers up, don't do anything until the throttle goes to neutral and then start doing something. But I'll add that logic later. All right. Now wait a second. Why was the voltage 0 for a bit? And 2.175 is too low. Okay, I definitely think I'm running into a voltage issue. I am sending the right voltage, or the right DAC value, 0 to 4095. I need to clean up some of the debug stuff out of this code. This not going to 2.5 volts is a problem, because that means as soon as I power it up, this thing's going to start to spin in reverse. And, I mean, where do I need it to get to 2.5? I have to come out of neutral. Okay. I think it's time to play with the bench power supply. I really, really wanted to make that its own video because it was such a kind gift, but I think I need to break it out now. I'll still do a video on it later. Okay, I'll be back in a bit. Okay, I've brought you back because I'm about to play with this, and I wanted to show the first boot up, because I've never used a proper bench power supply before. So this was gifted to me over Christmas by one of my patrons, Steve G. I feel bad that I haven't turned it on yet, but, well, you can see I've been largely distracted, and I really wanted to do a dedicated video on this, but here we are. I need it now. It is the Riden RD6024. Does up to 60 volts, which is pretty special for a bench power supply. Most of the ones I saw when I was looking only go up to 30 volts. I should be able to turn this on and set it to 5 volts. And that should be, it should be pretty straightforward. So let's do it. Oh, it's got a pretty screen. Okay. Voltage set. Oh, it's already set to 5 volts. It's 25 amps. I don't need 25 amps. And the cursor's at the end, but if I set that to... How many amps does this Arduino need at max? Well, let's try 5 amps. Okay, so it should be giving me 5 volts, 5 amps. Oh, that's how I turn on the output. Alligator clip on the negative terminal. Put that on the positive. So now the multimeter is connected to the output of the bench supply. It's showing 1 volt. 5 volts on the nose. Okay, turn that off, and it bleeds down really quickly. That pin is ground, and that pin over here is 5 volt. So I'm going to make up a couple of leads with the JST connectors on them so I can press them in, and I'll put the 5 volt in the ground onto here, and then power it from here. The code's already on there, so even with this not plugged in, I should be able to push this all the way to full throttle and see if I now get 5 volts. And if that's the case, that was my problem all along. I'm not going to make a GST cable. I'm just going to use these quick and dirty. They're rigid, so I don't have to worry about it. I can just push them in. Obviously, it'd be nice if I could take these leads and plug them straight in. I'm sure there must be an adapter for that. This is the first time I've used this, so I don't know. One thing's for sure, since I started this project, I've learned more than I ever thought I would. About sailing, about boats, about diesels, about electrics. It's been the experience. I should have fused this, but if anything goes wrong, I can pull this apart, so I'm not going to worry about it for now. So right off the bat, if this is the problem, where this was reading 2.1 in neutral, I should see it already be at 2.5 in neutral. No, it's still 2.14. I don't get it. I'm doing something wrong with this, with these DACs. All right, well, Andrew just got back to me. I'm going to turn off the camera and consult with him. I'm the digital mermaid, and I'm a dumbass. So you see how the red wire is going to where it says 5V? I had it into the V in. So I spoke to Andrew, and I explained what was going on. I explained that I thought I must be pulling too much power from the USB. And pretty quickly he was like, what's the voltage you're seeing on the input of the DAC? So I checked. 4.4 volts. VIN was giving me enough power to make me think I had it right, but not enough power to do it right. Once I realized that was the mistake and I moved the power over to the 5 volt, it was fine. Let me show you. Andrew was very kind. I was being pretty harsh on myself, and he laughed and said, don't worry. This is learning a new thing. You make dumb mistakes. So we're back to being powered off of USB. So I have to still put my, have this stop at 4.95. Remember, I removed that code when I was trying to sort this out. But you can see I pull it back to neutral. Wait, now it's giving me 3 volts, which is what it thinks it should be giving me. Right, I bet you the pot readings Remember I changed the pot readings? What is the pot reading? Input 5 volt, output at wherever you short out the pot. I screwed everything up. I screwed everything up. All of the things are screwed up. It's after midnight. I have officially hit the point where I'm too tired to be doing this. I really, 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 really wanted to finish this today. I wanted to be editing the video by now. Instead, I'm finally getting back to where I was when I sat down this morning. So I'm going to stay up a little bit longer, but for you, good night. I'm really trying to keep this to be a weekly release schedule. It is the day of the next, and it's already 7 p.m. So let's make of the day what we have. So I'm trying to remember where I left off. Yesterday was a long night. I know during the day when I was doing day job, I was looking up what I still needed to do before I can fire this back up again, and I came up with the switches and the pinouts. So the main things I've been looking at are the circuitry that I still need to do. I haven't done any of the configuration here. I'll do that when I boot this thing up. I think I've got all of the steps covered. A lot of the Regen stuff I'm not going to be able to do anything about until this is actually in the boat. So that'll be hitting pause for a while. At least I know the circuitry is technically there. I'm going to eventually build a little board and start putting the switches and stuff in it and build a real throttle. But I digress. That's why I wanted the Regen stuff here, so I knew what switches I likely needed. Once I can spin the motor, that's it. That's what I want to do today. Let's spin the motor. I've got that ground. All the grounds are connected. Throttle input is on 3. 3 is green. Okay, so that's that. Now where's ground? Ground is 20. And it should be black. Yep, it's black. Now I want the Regen. Regen is the brake pedal. Is that brake AN? When boost is disabled, pin 2 is used as the brake analog Regen mode. Okay, so pin 2 is brown, the bottom of this one. Oh, conveniently I used brown. Yay, that was a happy little accident. Do I have another ground? 6 is ground. Actually, can I just shove both of these into the same pin? It shouldn't matter, you know. The document said that all of the grounds are connected anyway. There. Okay, so in theory, Regen and Throttle are both now connected to here. Now I need to make a cable to bring the 12 volt down to here to bring into the common line. Oh, and I had several people after the last video correctly say, hey, make sure you tie your hair back before you spin the motor. And I will. Before I spin the motor, I'll tie it back into a braid. That's got to go to pin 9. I have got the half circle facing left, so pin 1 is this one here in this case. So there's pin 1, and I want the 12 volt into that pin. Now, I'm going to move this over here for now because I want to check that this is giving me 12 volts before I actually provide it to the chip, and I want to speak to Andrew to cross-check myself. So for now, we're just going to pretend that's plugged in. So this is going to go to pin 11, and I can confirm. I don't know if you can see that on screen, but that says pin 11. I really, 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 really appreciate what Kelly's done here. Okay, now we need to go to signal wire. Oh, I need to make my switches now. So let's see, what mechanical switches do I need? Okay, so from pin 11, that is going to be the foot switch. Where's my switches? So I have foot switch on pin 11. Yes, it is. Because, okay, so what I'm saying is pin 11 is D11 because D12 is where I'm reading the OPU switch. The throttle stop switch is pin 12. That's this one. So the foot switch is not being controlled by a real switch. I'm controlling this in software. So I have to go straight from here over to the controller. And where you see the foot switch, so if the OPU switch is flipped, I turn off the foot switch. If this is in the on position, then the foot switch goes true, and that sends the signal to close this. So let's do a yellow wire for that. Where did I say that's going? From Kelly 11, which is the 12 volt line, to pin 15, which is the foot switch. But I think I'm going to go straight to the foot switch. I'll confirm that with Andrew before I actually do that. If that doesn't work, then I will send it into here, and then the output will be closed to ground. Oh, maybe I should be doing that anyway. You know what? That's how we'll do it. So I have Arduino pins 2, 3, and 4, D2, D3, and D4, already allocated. I've got the foot switch on 11. I should have gone 11, 10, 9, 8. I should keep them all in a sequence. That's what I'm going to do. So I've got 12, 11, 10, 9, 8. Okay, so that's how I'm going to do that. So D10 is going to go into ULN pin 1. I don't think I'm going to need any pull-up or pull-down resistors. So the output here is going to be the thing that's closed. So when I provide a signal here, this will close and provide a path to ground. I think, oh, E, I have to run E to ground. That's where the ground goes to. Oh, this is so complicated. I mean, it's not, I'm just new, and that's okay. This is part of learning. Don't get frustrated. Don't get frustrated. Okay, now this chip is pulled to ground. The whole reason I'm going to such hassle on this helm control is that this is just the start. This is just setting up the beginning of a much, much bigger project. One of the conversations that often come up in the YouTube community is context switching. So you're building for a long time towards a certain goal, and you get a lot of people who are watching for that, and then you reach your goal, and, well, the reason a lot of people watch no longer applies. So my context, that would be when I finish this project and I get on the boat and I start traveling. Is anyone still going to watch? Well, I have years of projects ahead of me. So I may be changing scenery and being on a boat when I'm doing some of this work, but this content is going to be here for a very long time to come. Okay, so now this output goes to ULN pin 16 to Kelly pin 15. So Kelly pin 15, there it is, gray foot switch. And make sure that says 15. It says 15. Okay, the foot switch is now connected. By default, this controller is usually used in like road vehicles. So the idea of being able to go into reverse is a thing. I mean, to be fair, you can have reverse in the boat. My current boat's mechanical gears have that. I have a forward, neutral, reverse, and then a throttle. But because I'm going to joystick mode, I don't need that reverse, and the reverse is instead repurposed as the intensity of the regeneration. So what would have been the brake pedal, the brake pedal becomes the intensity of regeneration. Instead, the forward, neutral, reverse becomes a low, medium, and high speed. What does that actually mean? I ain't got a clue yet, but that's what this three-way switch is going to be for. So forward, neutral, reverse is 12 and 22. So this has to be read by the software. So this has to feed 5 volt in to 2 digital pins, which I said at the bottom I was going to do 9 and 8. 9 is going to be for high, which will be all the way up, neutral, and low. Oh, that actually worked really well, just loading that up and then touching it. Nice! That was much less painful. You know, the one thing that's great about starting off sucking at something is that you make progress really quickly, and it feels great. Wow, that works really well. Yay! Okay. I think I'm done with that for a while. The reason I'm saying that these are going to be the switches I use rather than just like setting them aside and buying more, these are IP67 rated switches, I believe. So I got these specifically to be able to work up on the dashboard on the sailboat. So they're like $11 each, Canadian. These are going to feed into here. Digital in, oh, and then I have to have digital out to here. So I'm reading from one pin and I'm going out to the other pin. Okay, okay, so that's sorted. So high in is 10, low in is 9, high out is 8, and high out is 7. Okay. It's complicated. So, I believe I now have this thing fully wired up. I have to update the software to be able to work this switch, mainly to make sure that neither of these are signaled high if this is in the neutral position. I'm going to update the software now, and then I'll bring you back. The code is done. Is it done right? I don't know. It compiles. That's about all I know. And then I decided I was going to bring you back. So here we are. But I have my business hair on. Let's see if we can get this thing spinning. I have no idea how long the video is by this point. I feel like I'm starting to enter into H-Bomber Guy territory for length. All of this mess here, it's a very accurate representation of what the inside of my head looks like. I'm going to load the software. When the OP switch is in the run position, the foot switch should go on. I should have a signal here. This, when it's in neutral, neither of these should have a signal. Like that, the green should have a signal. Like that, the blue should have a signal. Once I verify these are good, I am going to bring the 12 volt over to here and then pull these out one at a time and make sure that when I bring each one of these high, I get a connection to ground on this. How should I be able to measure that? Okay, well, one thing at a time. Let's test this first. All right. I would be shocked if this works at the first try. I've also added the other switches. What I was calling the OPU switch, I think, is just called main now, just because it was getting too confusing. When the code was simple, I could be cute. Let's load this. Make sure this is still working. It is. Okay. So I'm going to bring this back to neutral. So I know that this switch is off, which means run. So the foot switch is 1. Okay, I'm having the problem where these are bouncing like I had before. So I need to find this resistor and add this resistor. Pull-up resistors, I think they are. Really struggling at this point. My brain is really tired. I'm not sleepy, my brain is so full of crap. I'm having a really hard time keeping everything tracked in my head. It'll get easier in time. I know this. It's just because everything is new. If the controller reverts to default configurations, as it is now because it's new, I want to make sure that if the OPU switch is triggered so that the throttle is ignored, the 2 pins get set to no connection. And the reason is, if high and low, or, as they're otherwise known by default, forward and reverse, have no signal, it defaults to neutral, which is safe. So by setting this to fail-safe into neutral, mid-speed, it means regardless of what this is doing, it should ignore the throttle. So it's another layer of safety. Now if I set this, you can see that the main switch goes low, which sets the foot high, which tells this thing you can now listen to the throttle. If I set that, okay, that's low speed, which points to green, so that's correct. Go to high. High speed is bouncing all over the place. Okay, I need to figure out these pull up or pull down resistors. So this one is on when it's 0. So I have the resistor going to the positive rail, which makes it a pull up resistor. I want these to be pulled low, so I think I want a resistor to ground. I need to read the value of this resistor and get 2 more ready. I don't remember which one he had me use before, and my eyes are shot. Actually, you know what? It might be easier if I use the flashlight. Red, blue, green? Can't really make that out. It's a really small resistor. These are looking like, yes, these are my tiny resistors. 10K, half watt. Yep, these look right. Of course, the ones I bought the least of are the ones I'm using the most of. I thought it was red, blue, brown, but it kind of looks red, black, brown. Well, now that I know they're 10K, I could actually look up the color code. I don't think I should cook the resistor if I tried pulling down. So if I set this to mid-range, low is green. So if I take the green, what I should do is unplug it. Don't deal with a live thing. I'm going to do just one for now, and I'm going to pull it low. So that pulls the green low. All right, do I smoke it? Does it turn to a light bulb? No light bulb yet. No output at all yet. Don't tell me I already fried the fucking thing. No, I shouldn't have, because it should be able to handle... Okay, there it goes. Did I crash it, or was that a coincidence? Low is stable now. No, I saw it bounce. Nope, this isn't working. Okay, well let's try the pull up then. And the switch is off, so both of the values should be 0. Okay, 1 is not bouncing anymore. Which one is that? It's the green, but that's not the one I put it on. Okay, high is stable now. Can I switch it to high? I can. No, this is not working. The optimism of my braided hair might have been a little premature because I'm stuck. I need to talk to Andrew. It could be that I'm doing something in software wrong. Oh, there he is.
Hello.
Hello. So I tried putting the resistor as a pull up and a pull down. And let me flip the camera around so I can show you what I'm doing. Safe is 0. If the switch falls out, I want it to go to 0.
It's the opposite of your other ones. You want to pull down and then you want to apply 5 volts to it. Wait a minute here. That's a nano, right?
Yes.
You actually want to apply 3.3 volts to it.
Oh, so I need a 200 ohm resistor.
No, you just need to use the 3.3 volt power pin on the Arduino.
There's a 3.3 volt power pin?
Yeah.
Oh, okay.
You can use 5 volts for the I2C because it's pulled up inside in the Arduino, so it's okay to run your DACs on a different voltage.
Okay.
But in the case of inputting signals into the Arduino, you should pull it up to its own supply voltage, not beyond that.
Okay. So now these I want to pull to ground, right?
You want to pull down, yep, and then when you switch them on, then you attach those to 3.3 volts. Make sense?
The input is 3.3 volts. Oh, the input, yeah, the digital input. Yeah, sorry, the digital input.
You basically connect the digital input to 3.3 volts through your switch.
I see.
If the switch is open, then it gets pulled down to ground.
Okay, so, and I'm using these 10K resistors, the same as I used last time.
Perfect. Yep.
Okay,
that's the right one to use.
That is the right one to use. Let me move on to the ULN then, because that's what I originally wanted to ask you about. So this is the 12 volt line coming from the controller. That goes to the common, right?
That's right.
Okay, so that goes to the common, and then the outputs are going to be grounds, effectively. And I'm going to send them...
Effectively, when they're on. Yeah,
when
they're off, they're basically open circuit.
All right. I needed that extra vote of confidence. Well, this I was stuck on, but I only got stuck on this a few minutes ago. This is what I wanted a cross check on.
Yep. Oh, for sure. Yep.
All right. Thanks, dude. I cannot overstate how helpful it is to have people you can turn to. I think I've mentioned before on the channel, but maybe not for the newer user or viewers. One of the biggest things that made me want to start this YouTube channel was community. I come from the open source world, and one of the things that made me fall in love with the Linux community, the open source community, was how many people there were there to help. In the Windows world, everybody guarded their knowledge because that's how they kept their job. In Linux, everybody shared their knowledge, and I loved that so much. And when I got into sailing, one of the very first days I was on my boat, one of the people from the dock knocked and said, "Oh, you're the new owner of the boat." I says, "Yeah." He was really kind, and he says, "Well, if you have any questions or anything, you let me know." And later that day, I went over and I says, "I hope you were being honest, because I need some help." Couldn't figure out how to open up the seacock for my head. It was before I had the desiccating head. And he came over. Now, for any of you who come from the boating world, digging into the bilge, especially the bilge in the head, which is the toilet, is not a pleasant job. And this dude, who I had literally just met a short time before, jumped on board and he dove in. I love that kind of friendliness. In my weird little way with this project that I'm building, I wanted to start this channel for community building. That's how I measure my success here. And I should see 10K. Close enough. 10K. Okay. Let's plug this in and see if we're finally not bouncing. Why is it doing this? Let's just upload it again. Okay, there we go. 0, 0. So now if I flip it to low, 1. Neutral, mid, high. It's working. Okay, so let's start with all off. So this is neutral. Actually, it doesn't matter where this is now. Once the main switch is off, everything goes to safe values. So at this point, I should see no voltage from any of these. I hope that's legible. So right now I should have nada, nada, nada. So this is the foot pedal. So when I flip this, the foot pedal should go high. 1 volt. Only 1 volt? Why is it only 1 volt? Okay, well, I'll deal with that later. For now, the key thing is the foot switch is going high. So at least the logic in the software is right. So now, green is low, so let's connect 1 volt. And blue. There it is. Now, is the 1 volt digital pin out enough to close this circuit? Oh, at this point I can't do anything else until I turn the controller back on. The next step involves powering up the controller because I need the 12 volt line. So what I'm going to do is I'm going to move the 12 volt over, put this into safe. Okay, that is all the way off. Gosh, I'm nervous. I'm assuming there's diodes and whatnot inside of this. It's $1,000. They've certainly put in some basic safeties in, I'm sure, to stop a dumbass like me from breaking stuff. I hope. All right, I'm going to make sure the motor stays in shot for the rest of this because I have a horrible tendency to forget the camera and I want to make sure I catch this. I had a few people recommend using OBS, so that's what I'm going to try using for screen sharing on the Windows. So I have some programming steps I have to do. Plug this in, and if I say open, right, because I haven't actually turned this on yet. So all my outputs should be safe. I should be able to turn this on now. Now that's on. Now the 2, 3, 4, 2, 4. What's 2, 4? Throttle air on power up. Ah, okay, that makes sense because I haven't configured it for joystick mode yet. If I set this back to 0, oh no, it won't go to 0 anymore because that would go into the dead low. Okay, let's turn it back on. We'll ignore the beeping. Let's see if we can configure this. That is probably going to keep doing that. So the very first thing I want to do is open, COM3 opened, file, user, parameters. Low voltage to 40, low voltage to 40, over voltage to 58, over voltage to 58. TPS type is 1. I'll explain all of this later. TPS type is 1, okay, so that's good. TPS dead low, I want to change to 1, and dead high, I want to change to 99. So let's write that. Write successful. Parameter. That is annoying. Break type is 1. And then I want the break dead low to also be 1 and 99. Okay, let's write those out. Break dead low is between 5 and 40. Oh, damn it, it reset everything. Okay, so that's going to be 5. And I'm assuming then the high is going to be 95. I'll have to update the pot later. Break is regen, which we're not doing a lot of right now. Wrote successfully. Parameter. Joystick function is enable. Where's joystick function? That's what should quiet this thing down. Because I am putting out 2.5 volts right now, right? 2.45 volts, which I should be able to prove or verify here. Yep, 2.49. So setting to joystick should set this to be quiet. Where's joystick mode? Oh, is it over here? There it is. These are the toggle switches. Right. Success. Okay, now let's see if I turn this off and back on. Off. 1, 2, 3, 4, 5. On. Now it should be booting up with this thing in neutral, so it should be not complaining. Oh, thank God, it's not beeping anymore. All right, now that that's not being annoying, let's go through the configuration options more generally. The break dead low wouldn't let me go beyond 105, and I'm assuming 95. So I'm going to save that for now, and I'll have to update the firmware in here so that it stops. I mean, the regen range I'm not nearly as concerned about, and I'm going to worry about, you know, I'm not going to worry about it. 3-speed mode has to be set to 2. Is currently 0. Let's set that to 2. And right. Failed to read controller. Oh, right, because, but I did turn it off, so let's do open, user, parameter. Okay, so if you power cycle this, you have to reread the parameters. So that's set to 2, and I'm going to say write success. User parameter, and it crashed. Okay, that's why I keep sending the writes to it. Is it Windows? Is it the app? I don't know. Motor temp sensor is 1, might be 2. There's 2 types of thermistors, and I don't know which kind is in here, so that's going to be a little bit of experimenting. What's it currently set to? Motor temp sensor. Okay, so we're going to change this to 1, and then later we'll experiment with 2. Right. Success. Temperature. Because I don't have active cooling on this yet, I want to set the temperature cutouts relatively low. So I'm hoping that's reading. High temp cutoff is currently 130 degrees. Resume is 110. So I want to set the resume to 80 degrees Celsius for now. This is very low, and I know that. I don't care. And I'm going to set the high temp cutoff to 95. So the idea is this should stay cool enough that I'm not going to burn myself. Over 100 Celsius, I could actually hurt myself. Okay, can I write that? Write success. Let's go back to the Arduino for a minute. Actually, this has a monitor mode. User monitoring. Oh, nifty! It's like a little dashboard, so cute. So now, do I have 12 volts here? Yes, I do. So I'm going to bring this into the chip, into common. So this chip should now be alive. This is the foot switch. I'm being very careful because I know this is alive now. 0.2 volts. So now, oh wait, that's a ground, right. So if I flip this off, nothing's changing. I should be getting something out of that now. But it's tying to ground, so what am I reading? Am I supposed to be reading the 12 volt signal? I'm going to stick this into here, and I'm going to use that to let me pick up the 12 volt. Okay, so now I'm picking up the 12 volt, and I'm seeing 12 volts. So now, if I flip the OPU switch, it drops to 0. All right. We have a working foot switch. Okay. Bring this back in. I want to shut everything down before I try to jam these into here. So I'm going to move on to the next one, which is the low switch. And it's in neutral, so let's go. There's the high. Okay, so now make sure too, with the high, does it drop with the main switch? And it does. Okay. All right. Now the low. Okay, put this back into neutral, turn the system back on, and now I'm going to high speed. High speed is not working. Why is high speed not working? Oh, because I have the switch the wrong way. There it is. I have to wire it into here. We're not done yet, but I think the circuit is officially done. I mean, it's not done, not by a long shot, but done enough to spin the motor. Okay, turn this off. Set this to safe. Kill the power. Okay, now everything should be dead. Oh my God. Stop it! Mr. Kepler's not going to leave you alone, then you can come hang out with me, all right, bud? Failure, right, okay, so I'm going to close this because it doesn't like it when that goes away. Oh, buddy. At least you're still purring. Okay, he's reacting to my hand so he can see something. And shake it up now? All right. Kepler, be nice to Tatters, please. I think I'm ready to spin the motor. For anyone who's watched a lot of my videos, it's probably a little cliche to hear me say I'm really nervous. But I'm really nervous. My heart's going right now. Okay. Helm controls are saved. That's on. User monitoring. That's in neutral. That's my safety shut off, but this is my first shut. Oh, I've got a few ways to shut her down. Whoa, my Regen DAC is all over the place. Okay, but it sees the brake pedal turning. Oh, if the brake is on, is it not going to spin the motor? Okay, well, let's try. Very, very little. Still reading. Forward. Is it because of the regen? Oh, damn it. Okay, TPS pedal. Is the TPS pedal at least going up when I put it forward? I didn't pay attention to that. Forward, 4%. Okay, TPS pedal is changing. Why is it not? Damn it! Okay, the brake pedal's back to 255. Set that off. Set that back on. Does the brake, is it thinking the brake is full on right now? Okay. Low brake is 1. Let's try this again. Come on, please work. Yes! Oh my God! I'm sorry, I probably just hurt your voices, or hurt the mic. Guys, ladies, others, reverse. Neutral. Forward. The time it takes to ramp is too much. How low can I get the RPM? What is the RPM? Can I read the Why did I not see the RPM data? Motor speed, 440. I'm doing 440 RPM. Oh my God, you can't see the Oh! What did I say earlier about not having the camera in shot? Okay, well, you can tell it was working. Okay, let's bring it back to a stop. Okay. Yeah, the ramp is way too slow. But that's okay, I wanted to start cautious. Shall we go max speed? Whoa! I can feel the floor shaking. Okay, let's bring that down. What's the temperature look like? I hope my head wasn't blocking. Oh, geez, the tea's still warmer. But there's no load on it, so that makes sense. Okay, this is the end of the video. I have been so incredibly focused on just getting this thing to spin it all. Of course, the camera was missing it, but that's okay, you heard it. I have no idea what's next. I know I was going to talk about the helm control, so that's probably going to be the next video. I'll go into more details of all of the settings and whatnot. The wiring and all that. I'll do up a wiring diagram and blah, blah, blah. I only sound calm right now because if I let myself go, I am going to start bouncing off the walls, and I probably shouldn't do that because it's midnight. It works. You know, I think the last time I felt like this was the first time I had all 6 battery banks up and running. I had the screens here, and I think I said, I just want to take it in for a minute. That's exactly where I am right now. I just want to take it in for a minute. Okay. I need to start thinking about cooling loop. All right, I was so focused on this that as soon as it worked, I'm like, oh crap, what next? Do I have anything left to do? Oh yes, I have lots to do. I'm the Digital Mermaid. I need to go rest. I need to go have a very happy rest. Usual, if you like what you see here, like and subscribe. Really does help. Last video really proved that. Okay, thank you, bye.